Now this is a story all about how my life got flipped, turned upside down. And I'd like to take a minute just sitting right there. I'll tell you how I became the frog of a lab called MammPhys. In a small little pond, born and raised on a dissection tray where I spend most of my days, chilling out, drinking, relaxing, all cool, and messing with ethanol outside of school. When a couple of frogs, they were up to no good, started making trouble in my neighborhood. My senses got dull and my nerves got numb, and now here's what happened to my poor little nerves.
This shows the anatomy of a neuron. A stimulus changes the permeability of the membrane to sodium and potassium ions. This alters the distribution of charge in the cell body, and if the charge is great enough, it triggers a signal called an action potential. This action potential moves down the axon. The stimulus enters from the postsynaptic terminals in the dendrites. It is propagated through the cell body, down the axon, and leaves the neuron at the presynaptic terminals. Let's take a closer look at how an action potential moves down an axon. Voltage-gated channels in the membrane open and close depending on voltage changes across the membrane. When no stimulus is given, these channels are closed. A stimulus causes voltage-gated sodium channels to open. Sodium ions rush into the cell. The cell becomes positive on the inside and negative on the outside. The sodium channels close quickly while voltage-gated potassium channels open, allowing potassium ions to rapidly diffuse out. The cell returns to being positive on the outside and negative on the inside, and the potassium channels close. Meanwhile, the sodium ions inside the cell have diffused to adjacent areas, causing a slight change in the polarity of the membrane ahead of the action potential. This change in polarity causes the voltage-gated sodium channels in this part of the membrane to open. In this way, the action potential spreads down the membrane in a wave. Potassium leaves the cell, restoring the negative charge on the inside of the neuron. Meanwhile, the sodium-potassium ATPase pump has been shuttling sodium out and potassium in, re-establishing the resting potential distribution of sodium and potassium ions.
The absolute refractory period occurs when the region where the action potential was is left in a period when no action potential can be initiated from the second stimulus, no matter the amplitude. It is a result of inactivated sodium channels, and repolarization is needed to get rid of the sodium channel inactivation. After the absolute refractory period, sodium channels begin to recover from inactivation.
Ethanol has a single hydroxyl group on a hydrocarbon chain, so it is amphiphilic and can dissolve in the lipid bilayer membranes. This causes the lipid structure to become disordered and disrupts the optimal activity of ion channels. Some sodium channels become inactivated as a result of the disordered membranes and ethanol, which prevents the inward current of sodium. The membranes therefore do not depolarize as a result of the inactivation. At the same time, potassium channels are further stimulated. The increase in permeability results in an earlier hyperpolarization as there is a rapid outward current of potassium. The membranes become more negative inside, making it harder for the fibers to reach threshold. Because only some sodium channels are inactivated, the unaffected channels still depolarize the nerve fibers. The change in activities of the sodium and potassium channels result in a higher threshold potential and a lower maximum cap amplitude for the ethanol treatment.
I leaped and hopped here day after day, but my thigh got stabbed and now I'm in a daze. Got in the car and then to the ER. I met my doctor and said I better not have a scar. ER, yo, this is bad. I knew I should have stayed in class. Is this what the hospital's really like? Man, this really ain't cool. Oh look, here's an Embutol needle and all that. Now is this what I'm really in for? I guess so. I have no choice now. I'm not prepared to go out and under. MammPhys targets the ligand-gated GABA-A receptors, which also function as a chloride channel. The GABA neurotransmitter binds to a binding site on the receptor. Nembutol also binds, but to a non-competitive allosteric binding site. The binding of GABA triggers the opening of the receptor by creating a channel for the influx of chloride ions into the neuron. Nembutol is there to mediate the receptor by keeping it open for a longer period of time to allow more chloride ions to enter. The increase of chloride ions in the neuron causes hyperpolarization by making the inside of the membrane more negative. This is why the threshold increased when Nembutol was used on the nerve. However, the overall caps decreased because fewer fibers were firing, and the conduction velocity decreased due to the hyperpolarization from the chloride ions. The refractory period didn't change because the voltage-gated sodium channels were not affected. It was at night when I got in the fight. My thigh was still achy, but I wasn't shaky. If anything, I could say that it could have been worse, but I thought, nah, forget it. This is the worst. My teeth got knocked out about 7 or 8, and I yelled to my mom, yo, take me to the dentist. The lidocaine hit me, and that was it. So that's how I died in MammPhys lab.
Lidocaine is a commonly used anesthetic for dental procedures and works by blocking voltage-gated sodium channels in the membrane. These channels are responsible for signal propagation. This creates an anesthetic effect by preventing pain signals from being propagated to the brain. When lidocaine is administered to the sciatic nerve, it binds to the intracellular component of the voltage-gated sodium channel. It can only reach this component when the channel is open. Because the majority of these channels are closed until the membrane depolarizes, lidocaine will have no effect on the resting membrane potential. It decreases the threshold and maximum cap to 0. The conduction velocity also decreases to 0. In addition, no refractory period is seen when lidocaine is added.
I'm in heaven now, kids. Don't do what I did. Getting in fights and skipping school. I'll tell you one thing, it's not very cool. Just remember, ethanol's not the answer. Too much Nembutol won't fix it at all, and all that lidocaine can kill your brain.